Okay, guys, this is numbers 8 through 10 on the unit review here. We're going to go over a lot of graphing stuff here in this section. So the first part asks for the leading coefficient. So we can assume that there's arrows here on the ends of our graph. So if we made a line from the top left to the bottom right, that has a decreasing nature from left to right. Decreasing means that we have a negative leading coefficient. So that would be a negative to start there. For our factored form, this is where we want to pick out the roots. So here, this is at x equals -2. When we write that as the factored form, we change that sign to x plus 2. Now we want to look at the power that goes on that. If we look at the nature, okay, of that root, it has the nature of a quadratic. And we know if it's a quadratic, it has a power of 2. So let me edit that. So if we put a power of 2 on there, okay, it would be x plus 2 squared. And then we look at our next root. This is like x equals 0. And we write that as simply x. Now, you could write it as x plus 0 or x minus 0, but you don't have to. You can leave it just like that. And then, again, that has the nature of a quadratic, so that's going to have a power of 2 on it. And then our last one over here is that x equals 1. We would write that as x minus 1 because we changed that sign. Now, the nature on this one is a straight line. It goes through that axis at a straight line, so that's going to have a power of 1. If we add all of our powers up, the 2, and the 1, that's a total degree of 5, and we call that quintic. That's called quintic. Now, for our end behavior, as x goes to negative infinity, so negative infinity on the x-axis is here on the left-hand side, and this arrow is going up. Well, if we think about our y values are positive right there as that goes up. So we would say y goes to positive infinity. Then if we look as x goes to positive infinity there on the right, y is going down to negative infinity. So that's going to be negative infinity on the right. So we kind of say it as x goes to negative infinity. This is like the left. X goes to positive infinity is the right. So if you look at that arrow on the left, the arrow on the left is going up. Okay, the arrow on the right is going down. So up means positive infinity, down means negative infinity. And then let's look at domain and range. So for our domain and range, I guess I could have left my infinities in there. For our domain and range, we want to look at those arrows. So domain on this left-hand side over here, it doesn't end, it just keeps going. So we know that's going to be negative infinity. And then also here on the right-hand side, it keeps going to infinity. And then for our range, okay, this range is going down towards negative and going up on the left. So our range is also negative infinity to positive infinity. We can also write both of those as all real numbers. Totally up to you how you want to write that. If it says you need to write it in set notation or things like that, you can use the all real numbers. If you want interval notation, that's where you'd have to do your parentheses. So interval would be with parentheses, set notation would be all real numbers or with your inequality symbols. All right, number 9, so it says build a polynomial. When we build a polynomial, we first have to put that in factored form. So if we take x equals 0, the factored form of that, we could write x plus 0 or x minus 0 or x. Any one of those would be fine. We tend to write it just with x. It's just simpler like that. So we're going to just leave that as x. And then x equals -16 will be x plus 16. When we write it as a factor, we flip that sign. Now, if we look at these, we weren't really told any different degrees on them, so we're going to assume that they're good how they are. If we wanted to solve this, we would just distribute this x to the x and the 16. So we'd get x squared plus 16x. And that's our standard form. So when we talk about the different forms of equations, This one right here, the x times x plus 16, that's factored form. Okay? And the one down here, once we distribute, that's our standard form. Okay, so that's the main difference between the two. Is typically when we're building a polynomial, we start in factored form and we expand it to be into standard form. Now, when we're in standard form, we can see the degree. It's the highest exponent. So our degree is the highest exponent. So in this case, that degree is 2. Now, if it's an x squared function, that is a quadratic. Call that a quadratic. And our standard form, again, is that x squared plus 16x. This is kind of more of a basic version of that, kind of very small when it comes to expanding that. Now, if we go to number 10, we have 3 roots here. When we have f of -3, remember when we learned function notation, that's f of x. So -3 is literally replacing x. So we're saying x is -3. Here we're saying x equals -1. Here x equals +5. Now, if we're going to build a polynomial, we need to write those as factors. So x equals -3, we'd flip that sign, x plus 3. X equals -1 is x plus 1. And then x equals 5 is x minus 5. Now, for here, this is a little bit different than the last one. We have 3 parentheses going on. So we're just going to start with the first 2 parentheses, and we're going to go ahead and we're going to FOIL these. We're going to FOIL those guys. So here we'd have x times x is x squared. X times 1 is 1x. 3 times x is 3x. And then 3 times 1 is 3. Okay, we're going to go and put those in parentheses there. We still have this x minus 5 that we have to bring down. Now we can simplify these inside terms. Those are like terms. So all we're doing here is just combining our like terms. Okay, now remember, we're building a polynomial. Our goal is to get to standard form. Because right up here, this is our factored form. All right, so now we're going to distribute our x minus 5. So I'm going to take x and I'm going to distribute it to the 3 over here. So I'd have x times x squared is x cubed. X times 4x is 4x squared. And x times 3 is a positive 3x. Then I'm going to take my -5. -5 times x squared is -5x squared. -5 times 4x is -20x. And then -5 times 3 is -15. From here, we're really close to standard form. We just have to combine like terms. So the x cubed is all by itself. And then our 4x squared and our -5x squared, we can combine those. 4 minus 5 is -1. So it'd be a -1x squared. And then our x's, we have 3 and -20. 3 minus 20 is -17x. And then that -15 at the very end. And that is our standard form. Now, when we put it in standard form, it has to be in descending order, meaning highest exponent first. All right, so we're going to go back to the top, and we're going to fill that in. So our standard form here is x cubed minus 1x squared minus 17x minus 15. highest degree on that, that's right here, that's our x cubed. That's a degree of 3, and we call that a cubic.